I will give you assignment or kumbaga since 1:1 lang din si assignment at quizzes. So parang take home quiz na lang yun. That will be your first CS na lang muna. So next.
Face-to-face ipapasa yun, sir.
Ano yan?
Face-to-face ipapasa.
And I will be posting it in the GCR tas set ako ng deadline in passing. Siguro by Friday evening. Haba na rin yun. May Thursday and Friday pa kayo holding to do the assignment or take home quiz. And then sa Monday is discussion pa rin. Properties of steam. Kung ano yung natin, maiwan natin today since after diesel, discuss tayo ng properties of steam. And then, hopefully, next week, makapag-start tayo sa solving regarding thermo 2 na talaga yung steam or mga Rankine cycle naman. Sige. So, last meeting, recall natin, discuss natin yung Otto cycle or spark ignition or gasoline engine. I-review lang natin. So, basahin natin. So, the Otto cycle is the ideal prototype for spark ignition engines. So, the Otto cycle is an ideal thermodynamic cycle that requires 4-stroke with a piston and intake. Yung first natin or first process natin, first stroke natin is intake. Then, i-compress natin. Yun yung sa second natin. Kumbaga dito, di ba? Intake to ng hangin. Or intake yung parang 4 to 1 natin. Yan yung nag-compress yung process. And then 1 to 2, dyan na nagko-compress. Since this is isentropic compression. And then 2 to 3, dyan na nag-ignite yung loob ng cylinder. Then 3 to 4, after mag-ignite, magko-compress or mag-expand ulit yung ating piston. That's the adiabatic expansion. Then 4 to 1 ulit yung bukod sa intake, that is parang releasing na nung combusted gases. So, kulang natin yung TS diagram. So, pabaliktaran lang yan, parang mirrored. So, if in drawing pala the PV and TS, naka-curve dapat itong dito yung straight line. Naka-curve yan. Yan. So, volume constant dito and then volume constant dyan. Anyway, alam nyo naman na yan. Na-discuss na natin yung last meeting. So, the fuel and air mixture is compressed. An electric spark ignites it and spark plug. And the sudden expansion pushes the piston, producing a power stroke. And the spring action of the piston pushed the combusted gas away. And sabi ko kanina na. So, ayun, nag-solve na rin tayo ng problems regarding Otto cycle last meeting. Next naman sa ating internal combustion engines is the diesel cycle or compression ignition engine or CI. So in this cycle naman, the cycle begins with the intake stroke when the piston moves down and draws air into the cylinder. Ayan. So pag kumbaga, kung narating piston natin, piston cylinder, ayan. So initially, dito yung bore and stroke natin. Ayan. So pag bumaba yan, once na bumaba yan, so parang naging andito na yung piston head natin. Gaya na yung 1 to 2. So pag bumaba yan, nagdodraw yan or kumukuha yan ng hangin outside into the cylinder. Then the piston rises and compresses air. So process 2 to 3, compression, or 1 to 2 pa rin compression. So pag taas niyang piston ulit, kukompress niya yung air doon sa cylinder. During this compression of stroke, the air temperature rises about 480 degrees Celsius. So mabilis kasi yung compression, and then of course that is technically insulated kasi, so walang walang escape na air. So, uniform compression. Yung pag-compress natin ng air, nag-create siya ng temperature hanggang 480 degrees Celsius. Ayan. So, napakaliit yan na cylinder sa makina. Na compress yung air up to the extent na iinit yung air inside hanggang 480 degrees Celsius. So, pag init nung air, yan yung magkukos ng combustion. Basahin lang natin muna. So, this makes combustion when injected with diesel fuel retracting the piston to its original position. And so, pag compress natin ng air sa loob ng cylinder, yan. So, if mixed with, kumbaga technically, pag compress kasi niyan, meron tayong fuel injector dito ng diesel. Yan. So, nagmi-mix na yung fuel and then the compressed air combusting the gases. Okay, so, may naka open mic, nag-echo. I-close na lang. So, after combustion, siyempre, magre-retract ulit or bababa ulit yung piston natin. Technically. So, nag-create yan ng mga mixture of byproduct, flue gases, and then yung malinis nating power or yung heat natin na nandyan ay. And then, parang tataas ulit si piston para ilabas na yung heat or papunta doon sa parang makina. Yung mismong assembly. And then, the heat, parang mako-convert na yun into mechanical work or mechanical advantage papunta sa yung mga natin, shafts natin papunta sa mga gulong. Pag relating into automotive. Okay, so the downward stroke produces power as the gas is combusted and then comes to the exhaust stroke as the piston moves up again. And burn gases out of the cylinder, then the cycle repeats. Na-discuss ko na. Ayun lang. So, pala, fun fact or trivia. So, yung diesel fuel natin, yung diesel mismo, diesel gas. Kanyan, kahit technically, ulitin ko. So, kasi tayong diba, sa mga gasolinahan, merong mga kerosene, may mga gasolina, na unleaded, may premium, and then may diesel. Yung mga kerosene and gasoline, di ba? Very flammable yun. Kumbaga, kahit pag nagsindi ka ng posporo within a certain range is, or kumbaga yung pag sindi mo ng posporo and then may nahulog na parang mitya na gasolina is magliliyab agad ang gasolina. Ganun ka-flammable ang gasolina. Sa naman, sa diesel fuel naman, kahit pagsindi ka ng posporo or kandila, itutok mo or lighter or kandila, itutok mo sa mismong gasolina or diesel fuel, hindi yan nagliliyab. So, diesel fuel only combust or only explodes or only reaches its flash point kapag reaching certain or high temperatures naman. Kaya tinawag siyang compression, kumbaga compression fuel kasi kailangan mong i-compress yung air to the point na iinit yung air na ma-reach niya yung temperature para ma-combust yung diesel or umapoy yung diesel fuel natin. Ayun lang, fun fact. So, try nyo, punta kayong mga gasolinahan, ang Petron yung, tapos bili kayo ng diesel. Sindihan yan, silaban yan, hindi yan naapoy. Pero lang. Ayun lang. So, i-drawing natin yung PVTS na, PVNTS diagram natin. Mabilis lang, para punta tayo dun sa next. Huwag naman gagawin na mismo. Arasunlatan. Okay, so PV natin, since this cycle is Kumbaga, di ba, Carnot natin is SPST and then our Otto cycle is SVSV or isentropic, isometric, and dalawang so Otto is dalawang isometric dito sa adiabatic na yan and then dalawang isometric or constant volume. And sa diesel naman, this is SPSV or dalawang isentropic, isang isobaric or constant pressure and then isang isometric or constant volume. Okay, let's draw the given TS diagram. So, point 1 natin, dito pa rin yan. Parang sa auto. 1. So, 1 to 2, process 1 to 2 is isentropic compression. So, parang process 1 to 2 lang din ni auto yan. So, compress yan dito. This is our point 2. Okay. 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 Taas natin. This is our point 2. Then 2 to 3 is isobaric addition of heat. So isobaric that is constant pressure naman. So ayan, process 2 to 3 natin is parang ganito. Kunwari straight line yan. This is, as the graph says or as the diagram say, straight line horizontal yan. So pressure is constant or same ang pressure ng point 2 and 3. Ayan. So that is where the heat is added or yan yung QA natin. So maalala nyo yung sa auto, parang ano ito yung straight line. Sa diesel is ganyan naman. 2 to 3 natin is horizontal yung straight line. And then 3 to 4, we have isentropic expansion. Yan. And then 4 to 1 is isometric heat rejection. Constant volume yan. As the graph says. And vertically straight line, be constant. Sa process 4 to 1 naman, tayo nag-reject ng heat. So, andyan yung QR natin sa 4 to 1. And then, drawing RTS diagram naman. Sa ating TS diagram, this is just the same as the TS diagram ni Otto. So, it goes like this. This is our point 1. So, isentropic compression yan. So, straight line vertically. Since S is our X coordinate or X axis. 2 to 3 is isobaric heat addition. Ganun pa rin. Curve line going up. And then 3 to 4 is isentropic expansion. That is constant entropy pa rin or constant S. And then 4 to 1 is our isometric heat rejection. So heat addition natin, this is PC. Dito tayo nag-add ng heat. QA. And then this is constant volume naman or VC. Dito tayo nag-reject ng heat. Ayun lang. So I hope that's clear. Punta tayo sa formulas ng diesel cycle. Pwede yung screenshot yan. Ayan. So our formulas naman. So sa formulas of an cycle, pare-parehas naman yan. Pare-parehas yung main or general formula niyan. So start tayo sa work net. Our work net is still, that is QA minus QR. Sulat ko na lang. And then our QA here, since, and balik ko lang sa last slide. Ayan. QA natin, since nag-add tayo ng heat into the isobaric process or sa constant pressure natin, our QA will be equivalent to MCP delta T. Ayan. So maalala nyo sa auto cycle nung Monday, dito kasi tayo nag-add ng heat sa isometric. So ang ating QA sa auto is MCV delta T, kung maalala nyo nung Monday. So since sa diesel, nag-add tayo ng heat in isobaric process, naging MCP delta T or mass times the specific heat under constant pressure, then delta T. Okay. Next, our QR. QR natin, and heat rejected is the isentropic or isometric process 4 to 1. So this would be MCV, constant volume, specific heat, delta T. Ayan. So ano yung delta T natin? So for QA or for heat addition, MCP, our delta T is at process 2 to 3 kasi tayo. So if i-relate natin yan sa ating TS diagram, our process 2 to 3, mas mataas yung temperature 3 natin kaysa sa temperature 2. So that is MCP T3 minus T2. And then for QR naman, or heat rejected, that will be MCV. Yan. So, ano yan eh, parang negative T4 minus T1. Parang ganun din sa auto natin. Or we can say na MCV T1 minus T4. So this is kung kasi sa worknet. Take note pala, laging mas mataas yung QA than the worknet. Okay. Kasi bakit lagi mas mataas si QA kaysa kay worknet? Kasi if i-apply natin yung first law of thermodynamics, the law of energy conservation, let's say we have here one cylinder engine tayo. Ayan, this is our mismong engine. Meron tayong papasok na heat dyan. Ang mga lalabas pero is our worknet and our QR. Ayan, palabas ng dalawang yan. So technically, mass in, that is, or energy in, ang energy in lang natin is QA. Then our energy out are worknet plus QR. Yan yung mga palabas na energies. Kaya dito lang galing muna, yung umpisa yung worknet is equivalent to QA minus QR. So parang transpose lang natin si QR into the left hand side, making worknet is equivalent to QA minus QR. And transpose lang natin yan. So next, after QR, efficiency naman. So efficiency of the diesel cycle, ganun pa rin naman, the general formula for efficiency, we have work net all over QA. And this is our general formula for heat for engines, heat making engines. And so kung i-analyze natin further ang efficiency formula, meron tayong work net na QA minus QR. Over QA. So pwede nating ihiwalay si QA over QA. And and then QR minus QA. So magiging 1 lang din yung first term natin is parang magiging 1 lang. And then, pwede natin i-rewrite yung QR and QA as MCV delta T niya, that is T1 minus nating T4 na lang since dito tayo mag-big sa negative T4 minus T1 or either naman. MCP T3 minus T2. Yan. So ano pa ang pwede natin i-factor out dyan? Pwede natin i-cancel si mass. Merong CV and CP. But recalling from our Thermo 1, di ba meron tayo nung under specific heat na topic, meron tayo nung formula na CP is equivalent to CV times R. CV times K rather pala. CV times K. Kung ma-recall niyo yan, pwede yung balikan yung notebooks niyo later. Yan. So technically, we can rewrite this as 1 minus T4 minus T1 all over K times the quantity T3 minus T2. And i-enclose na lang din natin to para mas uniform. Yan. So bukod sa work net all over QA, if given tayo ng specific heat ratio and then na-solve natin itong 4 properties ng temperature, pwede nating ma-solve ang efficiency of the cycle. Ganun lang. What else? Yung mga compression ratio. Alam nyo na yung compression ratio, di ba? The RK. Compression ratio natin is dito nangagaling yung compression sa process 1 to 2. So still ang ating compression ratio is still V1 all over V2. Though applicable to sa both auto and diesel, meron lang tayong idadagdag na ratio which is for diesel lang to. For diesel, may idadagdag tayong ratio RC or the cut-off ratio. The cut-off ratio naman, this is equivalent to V3 all over nakarangan. V3 all over V2 yan. V2. Kaya makisingit dyan. V3 all over V2. Bakit? Cut-off ratio. Ayan. So, technically, ito yan. So, kahit na same tayo kasi ng pressure, technically, nag-expand yan sa part na yan, sa parts 2 to 3. That is our cut-off ratio in that certain process. RC and RC. Pinapulan ko pa. Ito rin. And then we also have, lastly, okay, meron tayong relation among RC and RK. Then meron na namang other expansion ratio, that is our RE. Yan, RE. This is RC parang A kasi yung C ko doon ay kanina. So, expansion ratio natin, that is V1 all over V3. Okay. And so, the relationship niyang tatlong yan, we have RK is equivalent to RC multiplied by RE. Or technically, we can say that V1 equivalent to V2. Yan yung ating RK. Then RC. RC is ito, V3 all over V2. Multiplied by RE natin, that is V1 all over V3. Yan. So technically, parang nag-cancel lang si V3 dito. Then naiwan yung V1 all over V2. Kaya, ganyan yan. Ayun lang. So, paki-screenshot na lang yung formulas. Important formulas yun is work net, QA and QR, okay, efficiency, of course. And then the compression ratios or ratios of volumes. So, mamaya, siguro after lunch or after machine shop, I will be sending the assignment or take-home quiz. Technically, take-home quiz na lang din yun. Sa GCR, either GCR or sa Messenger GC.
Sir, pwede po screenshot.
Yung alin? Yan, screenshot. Screenshot yan.
Yung sa una po, sir.
Okay. SPSV. Ano pa? Ano oras na ito?
Sir, yung auto din.
Auto. Meron na kayong ano, di ba?
Sir, yung formula din.
Formula ng auto, discuss na nung one day. Balik ko yung formula ng diesel. Okay.
Okay na po, sir. Thank you
So,
po.
sa iba, may questions pa sa iba? So, if wala, let's take a break muna. Then, around before 10, on or before 10, discuss natin yung properties of steam and then attendance after. Okay. So, if there are questions, just raise your hand or type nyo lang sa info messages, tas raise your hand para ma-notify ako. Okay. Yes, Mr. Jupiter.
Sir, pwede mag-excuse mamaya sa machine siya, workshop.
Bakit eh?
Sir, mga wata is scholarship ko dyan munisipyo.
Ay, okay, sige. Basta ano, basta sa machine shop nyo, sa Monday is quiz. So, siguro kung ano yung ma-discuss ko mamaya sa machine shop is send ko na lang yung PDF nun. And then yung PDF nung last week. Tapos review nyo na lang. Sabi ni Mr. Rosario, sir, pwede po pabalik. Okay, good na yun. Na ano ba, Mr. Rosario, na screenshot mo yung sa formulas and random diesel?
Sir, pwedeng pa ulit din.
Nung alin?
Screenshot.
Sige, wait lang.
Dun sa auto muna, sir.
Auto, na-discard ko na pala yung ano. Yung mga nakapag-screenshot, pwedeng ano na lang, send nyo na lang sa, pasend na lang ni Rosario sa GC natin. Intindihin nyo na lang yung sulat ko. Kapangit. Sabi ni Mr. Medina, sir, ibig sabihin po, yung diesel engine, yes, Mr. Medina. Only auto cycle or auto engines lang yung may spark plug. Kasi nga, di ba, when you, kumaga, pag tiniming natin yung spark doon sa air and fuel mixture, doon nagko-combust yung gasolina. Doon sa, kumbaga doon sa mitya or doon sa init nung pag-spark. Since very low heat, very low temperature, pwedeng mag-combust yung gasolina. Sa diesel naman, kailangang may compression ng hangin kasi doon sa pag-compress ng hangin, doon tayo nakaka-produce ng very high heat or very high temperature, which is what is required to combust or ma-reach yung flash point ng diesel fuel natin. So ang meron tayo is timing valve and parang fuel injector lang sa diesel engine. Wala nang spark plug. Ano, ang meron doon is parang glow plug sa mga diesel engine to preheat the fuel para mas madaling kumaga sa 'di ba pag ini-start mo yung mga mga diesel, mga SUV ganyan. Merong glow plug muna. Kailangan mo painitin mo lang preheat yung makina para mas madaling i-start. Yun ang kailangan. Sige, around 10 p.m., around 10 a.m. balik tayo. Tapusin ko lang yung doon sa properties of steam. Attendance act, don't forget. Huwag mo na kayo aalis or mag-AFK. AFK lang muna kasi pala. Begin, thermo to profit or subject profit. So first, we're going to deal with, before tayo magpunta sa mga power cycles of steam or regarding vapor, di ba? So gaya nung sinabi ko nung thermo 1 and then last meeting, sa kanina kasi, thermo 1, we're dealing with power generation or power emission na ang ating main circulating element is air, di ba? Thermo 1, that is air. And so we're generating power with the use of air. So bakit air, di ba? And we're mixing air with fuel para magkaroon ng power within the engine. So sa Thermo 2, we're gonna deal with power generation or power emission with the use of water. Ayan. So bakit water? Simply because water has many phases. Hindi lang yan solid, liquid, and gas. So technically, beyond gas, we have, or in between liquid and gas form, there is complicated or there is more properties between. So air kasi, sa Thermo 1, air kasi, this is a single state matter or single state element. Kumbaga, na-discuss natin sa Thermo 1. And then sa water, this is a multiple state or multiple state of properties ng element. Okay, so Thermo 2, properties of steam na tayo. So if we're going back dun sa P2 natin nung Thermo 2, nasa modules nyo kasi, tinalakay na natin yung properties of water nga lang. It is not steam, but properties of water. Okay. So if maalala nyo, meron tayong mga diagrams doon regarding this. Ayan. So this is parang mas malinaw or mas technical na kumbaga diagram nung ating saturation curve of water. So in this saturation curve of water, so di ba sabi ko dito, the most or the apex or the summit, ano ba, the apex part of the curve or kumbaga yung pinakamataas na point ng curve, that is our critical point. And so beyond critical point kasi, so diretso lang natin yan. Kung vertical pataas yan, diretso lang yan. So parang technically dito, liquid region pa rin dyan. And then here is our vapor or steam region pa rin dyan. Extended. And so, sa left ng ating i-review lang to ng anyway. So this is thermo to pa rin. So sa left ng ating curve, ayan, so this is our curve. Left niyang curve from our y-axis mismo hanggang or yung area ng y-axis. So lahat yan hanggang doon sa critical point and the saturation curve. Lahat yan, this is our liquid region or we can call that our subcooled liquid. Ayan. So next is yung mismong line na ito, yung curve na ito. Ayan. Our saturated liquid line. Ayan. So lahat ng points dyan or as long as tumapad dyan yung point, ayan, kumari, this point right here, anything in this point is our saturated liquid naman. Saturated liquid meaning nasa gitna siya ng phase between our liquid and then our vapor. Okay, next is our two-phase region. Ayan. Let's draw another line here. So sa two-phase region naman, hindi curve pala to. Dapat pala dito eh. Isin natin yung una. Sa two-phase region, this is a mixture of both vapor and then water. So technically dito, kumbaga imagine nyo yung loob ng kasirola pag magpapakulo kayo, di ba? Meron doong yung tubig na kumukulo and then meron doon yung steam, yun yung sobrang init na part ng yung parang pag binuksan nyo yung takip ng kaserola is mag-i-escape, di ba, yung parang usok. That is our vapor and steam. So under this curve or inside this curve pala, our saturation curve, that is where our wet mixture is found. Wet mixture, of course, mixture of liquid and vapor. And then sa right part ng our critical point, and this curve right here, this is our saturated vapor line or curve. So any point na naka-intersect dyan, properties dyan is at saturated vapor. Meaning, zero, wala nang dyan, wala nang tubig na, or wala, kumaga, kumukulong tubig, di ba? So, totally evaporate na yung tubig or wala nang moisture content dito sa curve na to. So, purely vapor na yung part na yan. Wala nang tubig or wala nang liquid state yung water dito, yung steam dito. Purely gas na yan sa saturated vapor line. And then sa right ng ating critical point or saturation curve line, this is where the superheated region is found. Superheated region meaning it is beyond the saturation vapor temperature and pressure properties is. So parang technically this is a sobrang init na vapor. So pag piniinit mo palalo yung vapor, 0% ng moisture yun or wala nang tubig sa vapor, then pinainit mo pa, and that is where the superheated steam occurs. Superheated steam. Kung hindi na siya vapor, technically that is steam na. Mas mainit sa vapor. Okay. So, definition of terms muna tayo since we're running out of time. So, in-explain ko na kanina, pero explain ulit natin with the definition na and then examples. So, first is saturation temperature. Saturation temperature, it is the temperature at which liquids start to boil or the temperature at which vapors begin to condense. And the saturation temperature of a given substance depends upon its existing pressure. It is directly proportional to the pressure. For an example, it increases the pressure. Example, the saturation temperature increases, the pressure also increases. And then if the saturation temperature decreases, the pressure is also decreased. Yeah. So from the definition, saturation temperature is where the liquid starts to boil or condense, or the vapor condense. So this is technically the border conditions of the properties of water before ito kumulo, and then before ito mag-precipitate or kumbaga mag-go back into liquid form or condense pala. So example given for saturation temperature is, ayan, letter A, water boils at 100 degrees Celsius at atmospheric condition 101.325. Yan. Water boils at 179.91 at a pressure of 1,000 kilopascal. Ayan. So that is the saturated liquid pa yan. Sa saturated liquid, properties yan ng water. So, sabi nga dito, if we have a 1,000 kilopascal na pressure ng water, it will start boiling pag na-reach niya yung 179.91 degrees Celsius na temperature. Diyan pa lang yan mag-start mag-boil. At the same time, pag we're talking about steam condenses at 311.06 degrees Celsius given na meron tayong saturation pressure na 10 MPa. So, ano yung MPa? That is just times 1,000 ng kPa. That is megapascal. So, kilopascal kasi times 1,000 ng pascal lang. So, times 1,000 pa, that is megapascal. Or pascal times 10 raised to 6. Kaya naging megapascal. Okay. And then last example is steam condenses at 39 degrees Celsius at 7 kPa. Ayan. So, malaking pressure kasi. So, mag-i-start lang yan, mag-turn back into what? Yung steam mag-i-start lang mag-turn back into water at 39 degrees Celsius given na 7 kPa yung saturated pressure niya. So, siguro hindi nyo muna hindi nyo nagigets or hindi nyo na sunamigi. Pag pala, I will require you to have a copy of our steam tables. So, pwede kayong bumili nung kulay green. Basta mga bookstore meron yun around, hindi ko alam ngayon, pero nung time ko, 200 plus. Steam tables lang. Hindi ko alam kung kay Santa Maria Hipolito ba yung author nun. Basta the cover is kulay green and then Manipis lang. Ayun, steam table.
Sir, ano ulit yung MPa?
Megapascal. Yung prefix lang ang napalitan from kilo to mega. Meron ding megapascal yung MPa.
Thank you, sir.
So, steam tables So, pwede kayong bumili ng book ng steam table. Pwede rin kayong kung hindi kayo makakabili ng book, siguro I will provide a copy na lang. Pwede nyo ipa-xerox next week, next face-to-face. Steam tables. So, sa steam table natin, makikita yung or mahahanap yung mga properties of steam and properties of water given this pressure and temperature. And so, independent variables natin yung pressure and temperature lagi sa steam tables, and then dependent variables na ang everything such as specific volume, enthalpies, entropies, as internal energy, and ano pa, enthalpy, yung apat na yun. Okay. And next, sa Monday na lang din, ituruan ko kayo ng interpolation na sinasabi. So next, for the definition of terms, is subcooled liquid. A subcooled liquid is one which has a temperature lower than the saturation temperature corresponding existing pressure. So example, a liquid water at 60 degrees Celsius and 101.325 kPa is still subcooled liquid. So since this is under the border of subcooled liquid and saturated liquid, so since we are given na liquid water pa yan, hindi pa yan nag-start mag-boil, ganun. So under this condition, this is still subcooled liquid. So kahit na tumaas lang yan ng 6, yun, 101.326 kPa or 60.1 degrees Celsius. So, yun. So technically, yan, pasok na yan sa wet mixture since that is beyond the saturation curve. Okay. Next is compressed liquid. And compressed liquid is one which has a pressure higher than the saturation pressure corresponding to the existing temperature. Compressed liquid is technically subcooled liquid lang na pinressurize or under higher pressure. Okay. For example, a liquid water at 110 kPa and 100 degrees Celsius is a compressed liquid. Bakit daw? Because at steam tables, PSAT is at 100 degrees Celsius. PSAT at 100 degrees Celsius is equivalent to 101.325. Since pressure is higher than the saturated pressure, therefore it's a compressed liquid. Sabi niya, under the steam tables kasi or under properties of water, di ba, ang ating temperature or pressure saturated sa 100 degrees Celsius para mag-boil is 101.325. But since this is still liquid water and then yung kanyang pressure is 110 kPa, so higher than 101.325 kasi, that is a compressed liquid. So kahit na maging 102 kPa lang yan, given na temperature saturated natin is 100 degrees Celsius, that is also compressed liquid. Kahit na 101.5 kPa, and that is also compressed liquid. Next is saturated liquid. Okay. Saturated liquid, then yung border line or yung pasok sa linya ng saturation curve natin. Saturated liquid is liquid at the saturations which has a temperature equal to the boiling point corresponding to the existing pressure. So, sa saturated liquid, it is a pure liquid or no vapor content. Kasi nga, andun pa lang siya sa borderline ng pagkulo ng tubig. Magpo-produce pa lang ng vapor yung tubig. Magbo-boil pa lang yan. Example, a liquid water at 101.325 kPa na pressure and 100 degrees Celsius. Liquid water pa rin daw yung tubig under 12 MPa, so napakataas na pressure and 324.75. Ayan. So, parang ito, 12,000 kPa yung 12 MPa. Ayan. So, under 12,000 kPa, mag-start pa lang daw mag-boil ang tubig at 12,000 kPa sa 324.75 degrees Celsius. Ulitin ko, parang dito sa letter B, magbo-boil lang ang yung 12,000 kPa na pressure ng tubig, magbo-boil pa lang daw yan sa 324.75 degrees Celsius. So next is vapor. Vapor is the name given to a gaseous phase that is in contact with the liquid phase, or that is in the vicinity of a state where some of it might condense. Yeah. Next, vapor, syempre, ayun yung na-produce or yung heat, ay, yung state, gaseous state na yan na it is 100% vapor. Ayan, yung saturated vapor natin is 100% vapor or has no liquid or moisture content. Ayan. So, pagbalikan natin kasi yung curve, ito yung saturated vapor natin. So, saturated vapor curve is in between the wet mixture and then the superheated region. Ayan. So, now, technically, it is a vapor with 0% 0% liquid or parang 0% moisture. So before siya ma-superheat, superheat ulit. Before siya ma-superheat, it is purely vapor muna. Yan yung saturated vapor natin. And for example, steam or water vapor at 100 degrees Celsius and 101.325 kPa. And so dito daw, parang naging saturated vapor na yung tubig pag na-evaporate mo ng buo yung tubig at 100 degrees Celsius lang na init, na temperature and 101.325. Saturated vapor in this condition is kapag totally evaporated na yung water. Totally vapor na kasi nga totally evaporated. So parang usok na lang yan inside the container mo. Another example, steam at 212.42 degrees Celsius and 2 MPa. Next is superheated vapor. A superheated vapor is a vapor having a temperature higher than saturation temperature corresponding to the existing pressure. And superheated vapor, yun na yung mga, yun yung technically, yan yung steam or superheated steam. Yan na yung either mas mataas yung temperature or mas mataas yung saturated vapor natin. Ito. Example of saturated vapor is steam at 200 degrees Celsius and 101.325 kPa. And since at 101.325 kPa, ang ating Tsat or T-saturated is 100 degrees Celsius. And sa example na to, in this example kasi, naging 200 degrees Celsius na yung temperature natin. Therefore, this is a superheated vapor. Next is steam. At so, mas madaling intindihan kasi ito is face-to-face, and then meron tayong mga steam tables na mas magigets nyo. Example is steam at 300 degrees Celsius and 5 MPa. And so, ang temperature saturated kasi natin at 5 MPa is 263.99 degrees Celsius. Since 300 degrees Celsius is greater than 263.99 under 5 MPa, and therefore, this steam right here, this condition of steam is superheated. And next is degree of superheat. So the degrees of superheat is the difference between the actual temperature and the superheated vapor and the saturation temperature of So madami pang kumbaga terms with regards to properties of steam. I will just complete this PowerPoint and then make a PDF of it. Saka send ko na lang yung kompleto sa GC natin, sa Messenger or sa GCR, yung PDF of this PowerPoint. Hindi ko pa kasi tapos. Okay. So, next meeting sa Monday, tutukan natin yung sa wet mixture na lang. On how to get the moisture content of the steam. And then, hopefully, we can start with the power cycles. Solving na tayo with thermodynamics. Monday. Okay? Question? Medyo magulo yung discussion natin. Hindi pa tapos. Questions regarding properties of steam before ko check yung attendance? Wala. Sige, attendance muna before